All right, last exponent rules problem here, or last exponential problem. And this is a disguised factoring problem. So the way I know this is a disguised factoring problem is that I have a trinomial going on here. I have square term, a singlet term, and a constant. So when we have a problem like this middle term we're always going to make into our u. Whether it was 4 out here and it's 2 to the x there, 4 to the x and 2 to the x, or e squared and e to the x. We're always going to make that middle term our u, and that's going to make things a lot easier for us. Once you say that's our u, we're going to say let e to the x equal u, and then we're going to do u substitution. So e to the 2x is u squared. E to the x is u. And now we're going to factor. So two numbers that multiply to negative 12 and add to negative 4 are negative 6 and positive 2. And then we can set both of those equal to 0 and solve. So I get u is equal to 6 and u is equal to negative 2. So that's like the computational part of this. Now we're going to take that and substitute back in what we know u is. U, we said from the beginning, is e to the x. So now we're going to plug that back in. If u is 6, that means e to the x equals 6. And if u is negative 2, that means e to the x equals negative 2. And in order to solve for x, I need to throw a log at it. So we're going to either use ln or log. Here, since we have an e again, we're going to use ln. The most common mistake with these problems is, 1, knowing how to start. Generally, if you can set up that e to the x equals u, you're good with the factoring part. Then here, it's making sure you take the ln of both sides. Sometimes we get so excited that we forget to take the ln of the other side, and then you break your problem here. So that taking the ln of both sides lets us bring down that x. Ln of e is 1, so x is equal to ln of 6. That's one of our solutions. Now, if you were dealing with 2 to the x instead of 4, you would have to divide that. If you're doing ln of 2 equals x ln of 2 equals ln of 6. Then you would need to divide that ln of 2 over. So just make sure you do that if that was the case for the problem. Okay, now let's look over here at our second solution. We have e to the x equals negative 2. Well, if I take the ln of both sides at this point, I'll be taking the ln of a negative. And we can't take that log or ln of a negative number. So this does not give us a solution over here. Because of the way our exponentials work, there is no exponent that we can give to give us a negative number. Remember, our exponentials all look like this, unless they're moved, unless there's a translation down, which you would have like e to the x minus 5 would move that down. You have that asymptote at y equals 0. So you can't have any output values, and outputs would be on that side if you didn't have these ln's here. You can't use an exponent and get out a negative. All right, that's number 8. Let's go ahead and fit number 9 on this video as well, and we will be done with our practice test. Okay, this is a little more complicated than the problem that you'll see on the test. And the thing that I do with these is make sure that I do them in small pieces. So I'm going to go off to the side and I'm going to take each piece and color code it for you, and we're going to evaluate each piece and then put it back together. So I need to do log base 6 to 16. That is a number. And then I'm going to do log base 7 of 42. And I'm actually going to do that with this. I'm going to do this all together. And then in the bottom here, we have log base 7 of 49. And last piece out here, log base 6 of 1. Okay, so each piece, I'll just work top to bottom. Log base 6 out of 216. I'll just make that x. So the way that these works, in order to solve for x, we're going to use the exponential. 6 to the x equals 216. And that one, you may not know off the top of your head. 6, I would hope that you would try 6, like try dividing 216 by 6. And so if you did that little division off to the side somewhere, so 6, 216, 6 goes into 21 3 times. That would be 3. 6 goes into 36 6 times. Little long division for you. So 216 is 6 times 36. And of course you know 36 is 6 times 6. So 216 is 6 to the third. So x equals 3. That means I can replace that whole thing, log base 6 of 216, with 3. All right, next piece. So log base 7 of 42 minus log base 7 of 6. Here, I can't evaluate log base 7 of 42 without a calculator or log base 7 of 6. But since they have the same base and they're up in that numerator together, linked by that minus sign, I thought maybe it could do the quotient. So log base 7, minus means divide, so 42 divided by 6. And 42 divided by 6 is 7. So that's log base 7 of 7. And anytime your base and what you're taking the log of are the same, we'll make that y, I guess. 7 to the y equals 7. So that whole thing in that numerator is 1. So I can replace log base 7 of 42 minus log base 7 of 6 with 1. All right, 2 more little guys to deal with, and these get easier as you go. So I'll make this equal to z, since I already used x and y. 7 to some power equals 49, and you may be totally ahead of me right now. I really hope you are. So z equals 2. So in my denominator here, 2. And the last one, I'll just make this a. 6 to the a power equals 1. And the only way we can get 1 is an exponent of 0. So we can replace that last term out there with a 0. So 3 plus 1/2 is our final question here. What's 3 plus 1/2? Well, it's 3.5. Or if you would want to write that as 3.5, that's totally acceptable. Or if you would want to write that as 7/2, that's lovely as well. All right, that is your log and exponential practice test. Again, the thing that makes this test more challenging, I think, is that you kind of have to stop and think before every problem and get a strategy in line. Which problem-solving strategy do I need to use on this problem? Because it is different between your disguised factoring problem and your, solve for x problem here. So you just need to make sure you have all of those strategies ready to go, and maybe even go through at the beginning of the test and label like what kind of problem each problem is before you get going. All right, I'm here to help. See me if you need extra help. There's also the unit review. So I know we did the practice test in class, and the plan for the unit review is just anything that you didn't get right on the practice test, that's what you need to be really hitting hard on the review. Make sure you can do those on the second. Are you ready for the test?